Hi everyone, in today's video I'm going to be implementing a feature in the Rebel Terminal Async crate. I've done 3 videos about the making of this crate, and originally the history is that I just wanted to create a crate which created a read line that was not blocking. So the normal read line that comes with standard in, it actually blocks the main thread, and it becomes difficult to have concurrent tasks that are running that actually want to output to standard out and also want to read from readline. So with this new crate, which I actually forked and I'm heavily modifying from Rusty Line Async, this actually provides the ability for you to take essentially make a command line interface program, a CLI program that is relatively straightforward to add some interactivity to, where you can actually ask the user for input, and while the application is running or the program is running, you can actually display output concurrently for multiple tasks without clobbering the prompt or the input that's being typed. So let me just show this to you real quick. So here's an example. So this one is terminal A6. So this one actually, so here I'm going to start. This is just an example from this repo. The Rebel Terminal Async repo. This is in the examples folder. So essentially what it does is that as I'm typing things, so this is a prompt, I can actually, as you can see, move my cursor back and forth within the prompt, and it's not being clobbered, and it's maintaining its correct state while there's a background task that's actually generating things concurrently to standard out. So it even has support for history. So let's start another task. So this one is actually generating output from Tokyo tracing. So this is actually fully integrated with Tokyo tracing. So this is a demonstration of that, where even tracing can generate log messages when you tell Tokyo tracing to generate log output or tracing output to you tell the subscriber to be standard out. This is basically a writer that allows those traces to be displayed to standard out, which is pretty cool. And so, as you can see, I can fully interact with the prompt while the tasks are running. So this is so while I was building that, I was like, well, another thing that is pretty useful is having a spinner. So this is an example of a spinner that supports the it's part of the terminal async. And so when you're running the spinner, let me show this to you again. So when you're running the spinner, it displays a message. That went by pretty quick. It basically displays a message saying connecting to server ... And then while that's happening, this foo messages are being displayed by some other task. And because this terminal async thing is pretty smart, it locked when the spinner was showing its output. It actually locked the standard out. So that all these other messages wouldn't clobber the output from the spinner. So it's either one or the other, which is pretty cool. And so that is in here. So if you look down here, there's the terminal async. This is how you use the crate. And then there's this thing, spinner. And this is the thing that we're going to be working on in this particular video, which is right now, it just shows these dots, which is okay, but that's some weird stuff happens with. I'm running this in Tmux, so it's not the most representative. Actually, let me just run it without running it. Actually, no, it's fine. This is actually what it looks like in a real application. So I'm also working on another, like a generic TCP API server that it's also open source that I'm working on, where this is the client for it, and as you can see, it says connected to server. That's the use of the spinner. And then when I typed exit, it uses a spinner as well. So this is another example of an application that uses this crate. That's this one. But we're not going to talk about that today. Today is focused on this particular issue, which is enhance the animation of the spinner. So currently there's just 3 dots that you see. I would like to replace it with Braille characters. This is how a library called, what's it called? Indicative does it. This is indicative. Let me show you this real quick. This is what I was using prior to writing my own, and it essentially allows you to. It basically shows progress bars, and it shows these spinners. So I needed something a little bit different. I mean, kind of similar but different, because I wanted to be I wanted to work hand in hand with this async read line. So that's how come this crate came into existence. So if we look at the issue that I created, there's not too many issues open right now. The task is to replace the dots with a spinner that uses a color wheel and cycles through characters. So color wheel is this thing that I made for my this one. Let's see. It's the Rebel Open Core. What is this? Where is it? 3BL Open Core. This one. So there I have a whole host of things in this text user interface, full-blown TUI library to do color wheels, which is creating gradients. Basically, you do like you have stops and steps where you say you want a certain number of colors and you have a certain number of steps that you want this library to take, and it'll generate you this nice gradient fill. It's like in a lot of like Figma or some other sort of graphics tools. You can see when you're creating a gradient, you tell them how many stops you have, which is the number of colors, and then you say how many steps, which is how refined you want the gradient to be, how gradual or drastic the transitions between colors. So we'll look at that later. But coming back to this, so yeah, that's color wheel. And the Braille one is what indicative uses, so we can start with that first. So this is the code base for the, where is it? This one, Rebel Terminal Async, and I already created a branch for this particular issue. And so let's just start into it. So one of the things that I did was created an enum to specify, just to kind of describe the types of spinners that we want, which is the ones with dots, which is basically what we have right now. I'm just calling this the one with dots. Then there's one with Braille, and then there's block. So one thing I'm going to do in addition to this video is make another one on testing, where I'll go through the journey of actually writing unit tests and integration tests, and possibly even end-to-end tests if they make any sense for this particular library. Before we get too far into this, one other thing this crate supports is it knows how to, let's see, where is it? This is the librs documentation, which is just README basically for this particular crate, but it supports, what does it say here, interactive? Yeah, so basically both terminal async and spinner, they can tell if your terminal is interactive or not, and if it's not interactive, then they won't show because there's nothing for them to do. So basically, if you say cargo run example spinner, it does stuff. But if you say echo, it doesn't do anything, because when this is the current behavior that's in there, it essentially, when the terminal is anything but fully interactive, they essentially shut off, because it's not clear what should happen, and so I didn't want any undefined behavior, so it just doesn't do anything. Because if you think about it, if you're piping input, let's say you're saying, let's give another example. I'll explain the reason why it's there is a reason. Let's see. Let's do terminal async. So here, this particular prompt is currently in raw mode. So essentially, what that means is that when normally in readline it's not in raw mode, which means that you type a bunch of, when readline gets called, it blocks the main thread. You type a bunch of stuff, then hit enter, and then readline will be unblocked, because the line in readline means that it will only like once you call it, you have to give it a buffer, and it'll only fill the buffer with a string which has a \n at the end of it. Until it sees the \n, it doesn't do anything. It's just blocked. So, and if you don't give it a \n, it will remain blocked forever. So it's one of the reasons I made an async readline, because I didn't want that behavior. I wanted to be able to kill a task, an async task, so you could abort them. But an OS thread, once it's blocked, it can't be unblocked. So it's not preemptive, and there's no way in Rust to kill it without nuking the process. So you can panic, or you can do a process exit. So here, given that when you were, let's say you pipe some data into this particular process, right? What should happen? Well, it's not using readline, because what's async readline actually just what it does is it puts a terminal to raw mode, and then every key press, every event that happens, it interprets it and it updates some internal state and then re-renders itself. So it's like a tiny little React application, if you want to think about it that way. If you've ever seen React, or any kind of like unidirectional data flow UI framework, like what's the other one? Elm, or there's a whole bunch of React similar things like Solid.js and stuff like that, or Vue. Actually, Vue might be a little bit different, but Solid.js and React, those types of frameworks, it's kind of like that, where there's an event loop. It's asynchronous, so it's not blocking. And so when you pipe something into this, it won't be able to read it, because, I mean, it can read it, but it won't be able to read it in the way that one might think, like a readline would read it. So for that reason, when you try to echo something, normally if it's a readline program, like if you ever like use like grep or something, you can basically pipe the output of cat into the input of grep, and then that'll do stuff. So here, this doesn't make a whole lot of sense, because this async terminal, the readline doesn't use readline. So it's looking for keystrokes, and so it'll just wait until you type something. And so basically, for that reason, when I detect that the terminal is uninteractive, that this defined default behavior is that it doesn't, it's a no-op, and it goes, your terminal is not interactive, so I can't prompt the user for information, so I'm just not going to run. But obviously, it notifies the user. When you use the library, it tells you that. It doesn't just silently fail. It has a very clear way of saying, okay, that's why if you look at this, it's called try new and not new. That's the try. Is that it kind of gives you a hint that, oh, okay, this may not what the heck, what, no, that this may not work every time, because it depends on whether the terminal is interactive or not. So with that on kind of covered, let's go back to this terminal async situation. So we have like 3 types of spinners: dots, braille, and block. This is implemented already. You can think of it this way. This is done. And color, you can have none, which is also done. So what is to do is these other items. So we can explore that in this video. Okay, so this is just an enum which just says, okay, these are the three different types. These are the two different color combos, and then there's a struct, which basically says you got to give me a style, you got to give me a color, and that is used when you create a spinner. So basically, and it implements defaults. So like this particular example, I mean, it just says use the default style, and the default style is what you're seeing here, which is that. So okay, but now we want to add, let's say, a few more other styles. So let's see how that might work. So there is, if you look at the code layout, there's a spinner example, and then the implementation of the spinner actually is spread across two different modules. One is this thing called public API, and this is the top level. This is the surface of the API that somebody using it is going to care about. And then there's a spinner implementation, which is currently doesn't have anything except for the style. And this is where we're going to put a whole bunch of the stuff we're going to do in this video. It's going to end up in this module and not in that one. So we're going to move a bunch of this stuff out. Make this much simpler as small as possible. Okay. So let's do this. Let's just checkpoint where we are. And let's see. So one thing, if you look at how this code is actually implemented right now, it all begins in try start. So the way it works, if you can, let's look at the example. So this is just an example for this example that we're seeing. That's this example. So what happens is the main function calls this example with other input function. Actually, this seems kind of redundant. Should just be able to, well, yeah, it's fine, because remember when you create a terminal async, it basically it might error out, and it errors out. It's slightly complicated, like the lifecycle. It's if it's non-interactive, it won't error out, but it will return none. But if there are issues putting the terminal to raw mode or getting the terminal size, then it will return an error. And I'm going to do a video on errors, just like I'm going to add another video to testing, because this is a big exploration. It's like, how do you think about these different states? Like, why is this returning a result which wraps an option? That's weird. Why? And so there's different reasons. Essentially, some situations are non-recoverable, in which case it errors out. Other situations are recoverable, in which case, so basically, if the standard in, if you're piping into this process and the standard in is being piped, then that's not an error condition, but that just means that, okay, I can't really display a prompt. However, if this process cannot get access, cannot put the terminal in raw mode, or it cannot get the terminal size, then okay, that's an error, because there's no way of continuing forwards with that. The whole thing won't work. You won't see anything anyway. So that is an error, and it should not happen. In air quotes, should not happen. Okay, so let us go look at the spinner now. So where it all begins is in the example we say, okay, make me a spinner, and it goes, there's some message, some delay. Delay is like how often should the spinner update. Terminal async is a reference to this terminal async. It says that you have to create one of these to do anything with spinner, because what happens when the spinner displays, it will disable or suspend this terminal. They work hand in hand. This terminal is the thing that's prompting the user for input, and this terminal is also providing a shared standard out that other tasks can use. They can clone it indiscriminately and write to it. If you're curious about those details, there's actually a nice issue here for redesign shared writer. Yeah, this is a whole other, maybe we can do this as a separate video, but there's a whole other thing that if you're curious about the implementation details of how all this is put together, that's a good issue to actually look at because it's got a lot of nice links and stuff in it. Let's see. Okay, so coming back to our spinner. So the last thing that you provide is a style, which, you know, just a default style in this case. Nothing that interesting. So what we want to do with all that out of the way is, that was a lot of context setting. Let's see. Oh, by the way, before this, I used to work, a couple of years ago, I used to work at Google where I worked on IDEs. Before that, I worked at Google where I worked on Maps API and Android in Maps, Google Maps API. And recently I've been working on an open source project, this one, which is creating a text user interface library from scratch. Essentially, it's reimagining how to take the great features from user interactivity and display, rich display, from graphical and desktop applications and web applications, and kind of like reimagining it for the terminal so that you can run it in a cloud environment. Like you could have it running in a virtual machine in the cloud in an instance that has no ingress, and then you could actually open a tab to get admin access to that machine, and you can actually install a program and run it there. And it's using it's a terminal interface, so all this works in there, which is kind of crazy, kind of awesome. And so that's kind of like, how would you build applications or reimagine things from to run in that environment, and a lot of the facilities that these kinds of applications require is just not there, hence having to write a readline implementation from scratch. So it's been an interesting yak shaving exercise to get there. There's so many pieces that have to be filled. Like you'll see later in the video when we talk about color wheels and how that works. That was a whole other thing that took a lot of time. So, but this should be much lighter weight because we're just focusing on the spinner. It shouldn't be that heavy. Okay, so let's see. We have, actually we don't need terminal async. So here, if you look at the logic, so in the example it says, okay, go, what does it do? Where is it? Oh, sorry, I'm in the wrong function. It's this one. Yeah, so in the example it goes, okay, make me a spinner with all this information in it, and then it goes, oh, this is actually it just makes this, it's just a dummy task that just waits for some number of milliseconds and just types, it just dumps foo into the terminal standard out. That's what this does. So this is going like, I think, what is it, delay milliseconds? Oh yeah, so 100 milliseconds. So it's going every 100 milliseconds, it goes foo. And while that's happening, because this is Tokyo spawned, basically the main thread is paused for some amount of time, about a second, and then once this comes back, it resumes. When I created that task that dumps foo, I just basically abort that task. And then it goes, if the terminal is interactive, then this will be sum, and so it goes, all right. If the spinner is sum, then go ahead and stop it. Essentially, if we ignore all this noise, it just goes try start, do some other stuff, and oh, that's actually do some other stuff. And when you're done with the other stuff, go ahead and stop. And so what we want to do is, where we want to focus today's session on is here. Okay, so we have the try start method. No, it's not a method. Oh, the try start associated function, because it doesn't take self. So the try start associated function probably returns something. Yes, it does. Okay, it returns the spinner instance. Okay, makes sense. So what this does is that it makes a spinner instance, and then it calls us, this is a method. It calls a method on the spinner. And this actually does the bulk of the work. It creates, this is the thing that displays the dots, basically this thing, trying to connect to server dot 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 dot. So that was coming out of this thing. So what it does is that the bulk of the work happens right here. So what we can do is that, as you can see, it does a bunch of stuff. Oh, this abort handle thing is when stop gets called, it needs to know that stop got called, and it does it using this abort handle field, this thing. And the reason this is wrapped in an arc mutex is because when you call try-start task, or actually when you call try-start, it actually ends up calling try-start task, which actually spawns. That's why. And so because it's spawning to be send and sync, I just wrapped the thing in an arc mutex. I think the mutex comes from Tokyo also, so it's an async mutex. So it's very, very Tokyo-tastic. Let's see. Okay, so here it checks to see whether the this task has ended, and if it does, it just breaks out of the loop because it knows that stop is going to do some cleanup right here. So kind of like, so you call try start, it calls this thing, it spawns a task, and when stop gets called by, let's see in our example here, then what it does is that it sets that abort handle to none, and then when that gets set to none, the next time this loop iterates, it goes, oh, it's none, and it breaks. That's roughly what happens. And then it also does a bunch of cleanup. And part of the cleanup is something we're going to have to modify. So here and here are the two areas that will be affected by our style. So basically we can say, and this can be refactored actually. Yeah, actually determine the output is based on the style. So here we have match self.style. Oops, no. Okay, so let's go look at what style is. Spinner style is that thing we were looking at earlier. It has this the style and the, wait, that's not a good struct name. Oh, this is type. Oops. Oh, type is not an identifier? Oh, right. What? Why not? It must be a keyword. Oh, yeah, of course it's a keyword. So this is kind. I don't know if these are good names, but we can come back and refactor them later. So let's see. So we have, where is it? All right, there's a mesh statement. So we're going to do, there's no style anymore. Let's see. Oh, still style. We should call it kind. This is not a good name. Let's do template. And we'll do template. I don't know if this is a better name either, but let's just go with this for now. So spinner template, and this is a spinner color. Okay, so let's see. So we can say style. So we're gonna basically do template. We're gonna do a match on the template. So later on we can do a match on the color because we also need to do that. That's a thing too, by the way. So what we can do is, oh, by the way, the standard out here is coming from this function, and because this needs to coexist with async readline, I am using standard error. Interesting things about standard error is that when you pipe it to a file, if you're dumping to standard error, it won't get piped. So, I mean, I use standard error, but this could also be standard out. There's really no real good reason for it to be one or the other, at least at this state. So here we can say determine the output based on the color. So this one is the template, the style template, and this one is the style color. Okay, so this is what we're working on right now. So interesting. So I don't know if any of this is valid, but that is just okay. Let's see what Copilot is doing. What is this? What? Doesn't make any sense. So what we're going to do is just put dots. Actually, we have this one. I'm going to do a to-do. You know, this is really just not that ergonomic. Let's just do it to say fill match arms. Thank you. And why did it go red? Oh, okay. So why it went red? See the self.style? It's in a spawn. It's an async block with move. So I'm just moving self. So one thing, you know, you'll see this here. It'll say something like let, and this is not mutable because, so we do something like this. We say self style clone. I don't even have to say clone because this is copy. So I can just say, oh, by the way, it's copy. So basically when you look at spinner style, you'll see that it's copy. Okay. So here we go. So I basically, this is a copy, and I'm going to move that copy into the async block, which is going to be handled to the executor to spawn on a separate green thread. So let's see. So we can easily fix that by saying style. Okay. Okay, so let's do this is that's correct, and then we can say template equals style template, and we can say color style color. Okay, so maybe we can say style template here and style color. So we're going to do style template here, have it fill in the match arms, and then we can do something similar to that here. Say match style color. Okay, and with the imports out of the way, there we go. So spinner template dots, and we know that if it's dots, we know that it needs to do this. And then we also know that it needs to do that. So there we go. So basically this should be a no change to the current code. Let's see. And if it's none, then we just leave it. There's really nothing. This is a no op. So essentially we've just retained existing behavior and just introduced this ability to match on the style template and the style color, and then later on this will be refactored, by the way, into this spinner implementation module, because this is going to get pretty complicated pretty soon, and we're going to make a trait which simplifies all of this. So, well, not simple, yeah, makes it more manageable. Okay, cool. So that's great. Wait, did it work? Let me just do this. Let me open a new tilex. Let's see, where is it? And then we can, let me get this out of, yeah, there we go. Yeah, I don't know what the problem is with tilex and tmux here, but it often results in issues. So just to be safe, let's do this. Okay. So that should be working. Okay, perfect. Yes. Let's just use this for now. Let's see if this is big enough. Yes, that is big enough. Okay. All right, so let us get at a. All right, so now that we have that working, let's look at Braille. So for Braille, it's interesting. Like there's this count, which is some state information that dots needs. So there's some. So basically, whatever these blocks are, they're stateful because like count has to be incremented here. So maybe we can move this in here. Unless, well, maybe they all need count. We'll see. Actually, they might all need count because it's counting how many times this thing this particular code path has been taken. So maybe that's why it's out of the match blocks. We can clean it up later. So this is basically that's the most useless comment. This is what is count? Well, not really. It's used to determine the output. And this is increment count to affect output in the next iteration of this loop. Because keep in mind, this is running in a loop until you break out of it. So that's what this is. Okay, so let's add that. All right. So for Braille, indicative. I looked in their source code. And this style thing somewhere. Progress style. That's it. So it's oops. I think it's progress style. Yeah, that one. And then for progress style, I looked at the source code and came upon this file, and look what I found. This is essentially, so the way the Braille animation will work is that there's count, right? So count needs to be used to cycle through these dots. And so count is going to be incremented every time, and so based on the whatever count is, it will need to affect like which one of these characters we select. So the algorithm, if you think about it, like this is our array that is fixed, but count is changing, but count is what is the word? It keeps incrementing in one direction. Monotonic, I think, or I don't know. Let's see, what is it called? Define monotonically increasing. Is that right? Maybe. Preserves. Never mind. Moving on. It just increments from 0, and like it doesn't get decremented. So it's not going to be like 0, 1, 2, 3, 4, and then 5, 4, 3, 2, 1, 0. It'll just be like 0, 1, 2, 3, 4, 5, 6, 7, 8, 10, 20, 30, 40, and keeps going. So we'll probably want to modulus it, the count, against the length of this array so that we can get the index that we need to show. And then what we'll probably want to do is then just be like, okay, pick, this item, then this item, and then so on, and then wait 33 milliseconds, display the next one, and so on and so forth. And then that's essentially the algorithm. So let's just implement it, and it'll probably be easier to express in code than my words. Actually, the lighting is dimming here. Let me turn the lights on. Okay, so in this algorithm, the count will increment by 1 for every iteration of the loop, and we have to derive the index of this array based on the count, which is increasing. So we have to use a modulus operator based on the length. We can already know that. So let's do this. This is the Braille one. So let us, before we do this, let's go make a const somewhere. Let's just put it here. Move it up later. Actually, let's put it here. Actually, you know what? Let's do this properly. Let's see here. So we can say const, and this is the Braille dots. What? Wait, is this right? Well, let's see. These look a little bit different. Well, let's just actually this is pretty cool actually. Wow. Yeah, let's just use the indicator for now. So I'm just gonna painfully one by one do that. That looks like the same symbol. It's weird. So this is, let's see. Okay. And then this one. And that one. Okay. Maybe what we can do is remove these. I don't know why it's putting that there. Then just do a bunch of these. And of course, this is going to be more than 8. So we got this. We got this. And then this. Oh boy. Oh, a lot more than I thought. Let's see. And more of that. More of that. And it just keeps going. Let's see. Okay. How many more of these are there? Let's see. Quite a few. Okay. Let's duplicate that a couple more times. Okay, almost there. This one. This one. That one. Okay. This one. Almost looks the same. Anyway. So there we have quite a few. Let's see how many of these there are. 30. Okay. Well, there we go. So there's our Braille dots as we have copied it from indicative. Because I really like their animation style, so let's just go with this. Okay, so there's 30 of these. Wow. Okay, so here we can, where's our thing? So what we want to do is, so we want to get the index into the, yeah, that's exactly right. And then we want to get the, wait a minute, message, no, actually it's the other way around. Almost, Copilot almost had it. So we want, so what this is saying is that, so it's saying the, take the output and, not take the output, it's saying that generate, this is the string that's going to be dumped to the standard out, which is, actually no, standard error, which is, the first is this Braille dot glyph, and the second is the actual message to clone, which is whatever the message that was passed in. So, you know, connecting to server. And then in the previous one, we had basically message to clone, which was whatever, or not to clone, the message was this clone. And again, it's because it's in a swan. That's why you had to clone it. Anyway, otherwise it would be moved. So here it puts the message first, and then it puts a bunch of dots after it. And it just repeats the dot count number of times. And here what we're doing is we're translating the index. Sorry, we're translating the count into the index. count into the index of the Braille.array, and then we're generating the output, which is just, pick the whatever the current Braille dot, and then put a space after it, and then put the message after it. And we can trim this later, so I'm going to put this. This is really a to-do. Make sure that the message clone is not too wide. Use terminal size. Okay, and we actually have terminal size in here somewhere. We'll get to that later. So I just want to make a mental note for coming back to it later. Because if the message is very long, actually this should probably be here too. Okay, and then let's see, message clone is not too. Okay, so here we take into account message clone. Then what we can do is there is one little trick when actually Copilot said it correctly. That's exactly right. That is exactly right. So what actually happens is that an artificial, quote unquote, artificial \n gets put in there, and that flushes the. Well, I don't know if that's necessary. We'll see. In my testing from previous iterations, this was necessary to put a \n because that allows this what I'm calling standard out to be flushed. There's no \n, then it wasn't eager to flush. So, but that may have changed. Okay, so let's see. Okay, and then what it does is that it prints whatever, and then it moves the cursor right back up. So prints it, right, and then moves it back up. And then the next iteration of the loop, it moves the cursor to the start, and then prints it, moves it down. Next iteration, oh sorry, the up, sorry, because it prints it, and then the cursor is still like far away from 0, and then it moves it back up, and then the next iteration moves it to 0, prints the string down. So it ends up looking like we'll see the output. It actually ends up working. So that should take care of this Braille dots one. So now let's go look and see about the stop part, because this also is contingent. So we can say match. So here we can just say self.style.template, and we can say this may end up being the same for all. I don't know, but let's just do this for now. That took care of the dots, which is what we currently have, and Braille is what we're about to do. So let's see what has to happen with Braille. My guess is the same. Yeah, you know what? I don't think it changes, because what this does is that it takes the final message, the stop message. So basically there's two messages. One is the start message, and this is, you know what? This should be the stop message, or the final message. And this should really be the, where'd it go? This is while the spinner is spinning, and this is when it's finalized. It's not spinning anymore. So here we can put, don't forget this. Okay, so let's see, does that compile? Yes, it does. Okay, so now let's just run it and see what happens. So what we're gonna do is, when we created this spinner, I had just lazily set default. So now I'm gonna say, what the heck is this type? Actually, there's a way to find out from here. That's not very helpful. Does it say the type? Really? Oh, nope, doesn't say the type. Interesting. Okay. Does it say the type here? It does in a really not easy to read way. Okay. So, what was that? Oh, this is spinner style. Okay, so let's just get this. So we can do spinner style, and let's bring this in. This is, so we need a template and a color. So we're gonna say template, we want Braille. So, and we leave the rest of the fields as default. So do this. Okay, that compiles. Perfect. So let's run it. Okay, so that's too short. Let us make this artificial. It worked though, which is pretty exciting. So let's make this longer. What's this? Where is the... Okay, so artificial delay, I think, is how long it sleeps. So basically, if this is really long, yeah, let's make this really, really long. So it'll be kind of like strange, but we'll see it. And also I have another task, I'm pretty sure, that's building. Yeah, I have a cargo watch basically that I run in tmux session, which basically just constantly keeps rebuilding the code in here. That way I don't have to keep running cargo. Although cargo build, although when I do cargo run example, it recompiles it anyway, so that's kind of redundant. Oh, there we go. Look at that. Look at that. Oh my goodness. That looks pretty cool. Wow, look at how many foods got printed in the meantime. Okay, that totally worked. Look at that. Sweet. And this cursor, the reason it's stuck at the end is because, oh wow, very cool, very cool. All right, the reason it's stuck at the end is because, it's because right there. It basically prints the string, does a character and line feed, then goes up one, and the way it works with this is cross term. So when you say foo character and line feed, it's actually just it just does a backslash n, so it's a new line, and then it doesn't move the caret back to position 0. So if we were to do this, so this order can be changed, it doesn't really matter. What we'll see is slightly different behavior. Nope, it's exactly the same behavior. What? Interesting. Yeah, it would help to put this in the right place. Wow, they look the same. Okay, so I don't think we'll need so many different. It's materializing like what trait to extract from doing this exercise, because it's hard to predict these things up front. There we go. See, the purple thingy is at the start rather than at the end. So let's see. So if I do take that out, the purple thingy will be at the end. So we'll leave it at the end for now. Okay, so I think, let's see, so that does Braille. This is working really well. Let's commit this. Block. I wonder what I had in mind with block. Glyphs. I think I know what I had in mind with block. It's very similar actually. It's almost the same thing. So this block thing, I had this idea like there's all these different shapes. Like, by the way, this is see. Let me log into this real quick. So ANSI 256. So these characters are not Unicode. They're just part of ANSI. So they display as is. Like if you look at my powerline prompt, these are using all these funky symbols. All these are from here. There's actually you can. There's a website. Let me see. I think it's config. I think the website is this one. You can. Nope. Let's see. You can see it here. Actually, it is Unicode, but oh, never mind. So I guess these are like characters that look like graphics, but they're not. They're just Unicode characters. So these are not ANSI escape sequences or part of the ANSI character set. They are Unicode, but they're not like emoji. So they're not like grapheme clusters where there's the width is wider. Like a smiley face is actually much wider than just one character width. It's also, I think, in memory it takes up more space. I have a whole section on that for Unicode. Let's see, Rebel open core Unicode string. This took months to build. Where is it? Unicode string. It is in here somewhere. I think this is the wrong crate. Which crate is this? I think it's DocsRS Rebel core. Not the best name. Unicode. There you are. There's a whole long. Where is it? Graphemes. There we go. This document goes into a huge amount of detail about grapheme clusters and how to think about them, and the display width, which is how wide it is on the screen versus how wide it is when in memory, like how much space it occupies in memory. Like normally it's 1 wide and 1 byte, but for graphene for Unicode it's different. You can have like check this out. So the smiley is like, so I was saying like 1 byte in memory and then 1 display width like that. But this emoji is actually wider. It's actually bigger than like 1. It's actually in memory 4, but display width is 2. So it gets complicated fast. Okay, coming back. So these are just Unicode's fun Unicode symbols, and you can find more of them here, by the way. There's all kinds of interesting like categories. Like you can see, like I found all kinds of interesting stuff here. Which, let's see, let's look at currency symbol, for example. So like this kind of stuff, dollar signs. There's like other symbol. Yeah, all kinds of cool stuff. Like what's a cool one? Eternity sign. Very cool. Wow, all kinds of interesting stuff. So we could actually use these if for animation. I mean, like the Braille array. We could put a bunch of these, and that would serve the same sort of purpose. But anyway. So what I was thinking is taking this one, these sorts of blocks, and making it look like it's animating. So basically, it would be roughly taking these, and you can imagine like making many different variants of them. So it would be something like const block dots Wow, that is pretty cool. Okay, that's pretty awesome. It kind of read my mind. Wow, because that's what I. Oh wow, that's really cool. So here we had. We'll do that painful exercise again. So we do the one, do like that. So let's say. Let's do. It's only 4 of them, I think. So we probably don't need these. Okay, so. And also there's a way to disable Rust formatting if you don't want it. So right now it's just putting them all in the same line, but I can tell Rust format for any given expression. I can just say don't, or block. I can say do not do Rust format. Okay, so my thinking was we could do something like that, but there you go. Essentially just goes back and forth and back and forth. So basically can do, actually let's do 8. Okay, sure. So it starts here and it kind of goes to the next one, cycles to the next one. So block dots. All right, so let's go in here. And I think this will look almost exactly the same, if I'm not mistaken. So, yep, that is pretty much exactly right. Block dots. So basically we're just using, instead of braille dots, we're using block dots, the same modulus operator and everything. Okay, let's see what this looks like. Here we can say that was braille, so now we can say dots. Sorry, block dots was the default. Whoa, that is super cool. It's pulsing. Okay, this is awesome. This is kind of like what I had in mind. And it panicked. Why? I probably did something. Oh, that's, I don't know why. Spinner. Huh. Public. Does that stop? Yes. Oops. And I think this is exactly the same. So this is actually much easier than I had originally anticipated. Ah, and I had this super long delay. I don't think it's necessary to have 100, maybe like 50. Let's do a binary search. Let's see if this looks okay. Oh, that is sweet. So then that's not bad. And then let's see, one thing we want to do is, and this is where like we'll just take this to the next level, which is colorizing it. This is going to be epic. So let's see. So I like to keep my streams about an hour, so I think I'm gonna stop here and do the colorization as another stream after this one. But this has been more progress than I was expecting. This looks really good, and the colorization. What it'll do is that. So let me show you an example of this colorization thing I'm talking about. So see this TCP API server. So this string is basically colorized like green, going to yellow, going to orange, going to red. And the code to do that is really straightforward. It's because, let me see, it looks like this. Remember I was telling you at the start of the video, there's like this color stops and steps. So basically this goes, hey, I have 3 colors. These are the steps. Sorry, these are the stops. These are the steps. And this is how quickly, this is the, actually gradient, not speed, gradient smoothness. Like, do you want abrupt transitions between colors? Do you want like very gradual? And they kind of work hand in hand, the steps and the smoothness. It's a bit of a heuristic. So you have to play with it until it looks right, basically. But essentially, we'll be taking one of these color wheels. This is from the Rebel 2 crate, and just using it to colorize the cursor, because it's smart enough. It actually has an index internally that it manages, and so you can just say next. It's an iterator. You just say next color, next color, next color, and it just basically will go through the whole color wheel, come right back, go through the color wheel, come right back, and it'll do it in a really, really gradual way, so you can't even tell that it's looped back around. So it's trivial to actually put this in. And so if it's trivial to put it in, maybe, let's see, so right now, okay, so what we'd have to do is, see the output is generated here. Instead of printing it, it would need to be put through this color function that would colorize it. And then it would need to be printed. So that's the only step that needs to be done. Yeah, so it's going to take more than, I mean, it's not a lot of work, but I think this is good for today's stream. So on that note, thank you for watching, and I will see you in the next one. And also, if you like this style of video, please give me a thumbs up, and please subscribe to get notifications for when I drop more videos. And also, if you go to developerlife.com, this is a video channel for the website. You can subscribe to the mailing list, and whenever new content comes out, whether it's tutorial-based or video, I usually send out a newsletter there. And yeah, thank you for watching, and I'll see you in the next one. Bye.